everyone, it's Christy and welcome back to another weekly calculus video. If you haven't subscribed yet, make sure to subscribe below so that you can see these weekly videos to help you with your learning of calculus. In this video, we're going to be looking at the volume of a region, a three-dimensional region. And if you'd like to watch other videos where I talk about area and volume, which are common topics at the end of a Calculus 1 course, make sure to check out my channel to see all of those videos. In this problem, we're going to let the region R be the area enclosed by the function f of x equals 3x to the 1/3 power and g of x equals 3/4 x. We're going to find the volume of the solid generated when this region R, which you can see in the diagram below, is revolved about the horizontal line y equals 8, which is also sketched in the diagram below. So what we're going to be doing is we're going to be taking this irregular shape that's formed by the area that's enclosed between these two functions, and then we're going to revolve this region about this horizontal line. Now, I have to admit, drawing this is a bit hard, so instead of drawing it, I'm going to show you this visual. And here it is. So seeing this, you can think about that region and think about being revolved just like that about this horizontal line, y equals 8. And this would be that axis of revolution. Now, what I want you to do is I want you to picture this. I am going to take one slice of this region, one cross section, let's say. So I slice it down the middle, I pull out that cross section, and I face it towards you. I want you to think about what that shape would look like. Well, a lot of people call that shape a washer. And the reason is because you've got this inner circle and you've got this outer circle, and so, which, by the way, those are horrible circles. But if those were perfect circles, you can think about it's almost like this washer that you would use to, I don't know, do construction and stuff. Clearly, I'm not a construction worker. Okay, so think about that washer. And what we're going to do is we're going to add up an infinite amount of those washers to get the value. And because we're summing up an infinite amount of washers, we need to use an integral in calculus. And calculus allows us to find the volume of this region, which I think is so fascinating and so cool that you can use calculus to find this. Now we have to put our lower and upper bounds. And because we are adding up an infinite amount of these washers, we are starting at the x value of 0. And it appears that we're going to the x value of 8. And the reason I'm using x values is because we're revolving this region about a horizontal line. And when you revolve a region about a horizontal line, you're taking cross sections going vertically, which means you're going to use x values. So like I said, it looks like it's 8. So let me just make sure that that's where these two functions intersect. So if I find f of 8, I'd be finding 3 times 8 to the 1/3. 8 to the 1/3 is 2. 3 times 2, I do in fact get 6. Likewise, if I find g of 8, I'd be taking 3/4 times 8, which is also 6. So yes, it looks like these two functions intersect at the point 8, 6. So I would be using the x value of 8. Now, what I need to do then is I need to add up an infinite amount of these washers. That's why I use the integral symbol. And then I need to think about, well, what is the area of one washer? Or how can I represent the area of any washer, really, from this situation? Well, if we think about this, what we really have, if we want to find the area of this pink shaded region right there, what I like to think about doing is I would need to find first the area of the large circle, the outside circle. Well, to find the area, let's call that radius capital R. The area of that outside circle of the washer would be pi times the radius squared. And then I would have to subtract out the area of that inner circle. And let's call this radius lowercase r. So I would subtract out pi lowercase r squared. And that's how I would represent the area then of that pink shaded region of the washer. The only thing I need to do then is use this problem to replace the large radius, capital R, and the small radius, lowercase r. And I'm going to find those by looking at the picture. So what I have sketched here, well, if I look from the center of the circle, well, that would be from the axis of revolution. That would be the y=8 line. And I go to the very, very outside. That right there is going to be my capital R. And to find that, it would be then the difference of those two functions. So in our case, we have pi, and then that capital R would be the difference between 8 and the lower function, which is the linear function. So that's got to be g of x, 3/4 x. And then you would square that. Minus pi times the radius of the inner circle. And if I sketch that in the picture, that would be from here to this inside function, and that's going to be my lowercase r. Again, you would find lowercase r by taking the difference of those two functions, which in our case then would be 8 minus, and that curved function is the 3x to the 1/3 function. And then you'd square it. Okay, so that would represent the area of any of these cross sections, which are really washers. And so now we need to put that into the integral. Notice both of these have a pi, so I'm going to factor that pi out and put it in front of the integral. And then I would just put whatever's left, which happens to be the capital R squared minus lowercase r squared, and I'll go ahead and enter that in here now. And because I am summing up an infinite amount of these cross sections that are washers between 0 and 8, and the cross sections run vertically, this is going to be a dx problem, which absolutely makes sense because the variable that I have used already is x. dx represents that thin width of each washer. And from here, I'm just going to type this into my calculator, which I've already done, so let's take a look. Let me move my head out of the way so you can see what I have typed in. And hopefully I've typed that correctly, and press enter. And there it is, a volume of 361.911. Let's move my head back, and there we go. A volume of 361.911. And again, we have just found the volume of the solid if you take this region, which is enclosed by f of x and g of x, and revolve it about the horizontal line y=8. I hope you found this video useful. Once again, if you did, make sure to give it a like, comment below about any questions or comments you have about this video, and don't forget to subscribe so that you can see other calculus videos and be notified when those videos are available to help you in your calculus learning. Have a great day, everyone, and we'll see you in the next video.